who form a tree hierarchy where each employee has a boss except for the general director. Task is to process Q queries of the firm who is the lowest common boss of the employees and behind the hierarchy. Okay. And the number of Q the queries. Okay, the employee 1 is the general director. The next line contain for each employees 2 3 their bosses. Okay, so that means okay, we can get for each employee their bosses. So for 2, who is its boss, so we can attach an H. Finally, there are Q lines containing each query. You have to Q who is the lowest common boss. I think it's a LCA problem, right? So we are NQ, then 5 means n minus 1 integers. Who is the boss of 2? Who is the boss of 3? Who is boss of 4? Who is boss of 5? Okay. Now, so 2, 3, 4, 5 are connected to 3. Now, who is the boss of 4, 5, 2, 5 and 1, 4? Okay, got that. So let's write the LCA code directly. There is nothing in this. Okay, so how to write the LCA code? So vector of, let's create the adjacency matrix of next. What is n? 2 raised to 10. Okay, that is fine. Then we have the log is, let's suppose 24. Okay, 2 raised to 24. Okay, I will say, so first calculate the how to find LCA. Sparse table for populating the sparse table, we will have to run a DFS who are the jth 2 raised to jth parent of this node. Okay, so I think we can apply DFS from 1 with the parent as -1. Given the, we'll take the input, given the what is the node, who is the parent, and then we can go that parent of CPR, parent of U is directly the parent, and who is the direct parent, so sparse table, right? So we have the vector, or we can say PR of next to log. Okay, let's make it 25. So to 0th parent of this is parent. Okay, and we can call, so depth, we also need the depth of this. Okay, let's have the depth matrix also, and depth of each node. So we can say depth of U is nothing but 0, or we can say is 1 plus depth of parent. Who is the parent? Who is the direct parent of U is nothing but the given parent. And what is the depth of U? Is nothing but 1 plus depth of parent. But what if my parent is -1? Make 0. Let's calculate depth somewhere else. So depth of U, let's calculate. Okay, so we can go through all the adjacencies, all the edges of U. If V is equal to parent, then continue. Otherwise, let's calculate the depths other parents also. Parent, I need the jth parent. Okay, 2 raised to jth parent will depend on 2 raised to j minus 1. So let's increase it from here. So j less than equal to log j plus plus, we can say who is the parent of this node, who is the parent, jth parent of this, we can say j minus 1th parent. let's get the j minus 1th parent of u, and whatever I got from there only I can get j minus 1. Okay, this way all the parents of u are calculated. From here we can say depth of v, this child's depth, is equal to 1 plus depth of u. Anyways, u is 1, so every depth is 0 initially. So depth of 1 is 0, then 0 plus 1, I think, yeah, it works. So then call v u. This way, for every node who are their parents, this sparse table is calculated, this parent matrix is calculated, right? So for u, what is the parent? Minus 1, and go to all the nodes, go to all the powers of 2 till log, and do this. Who is the jth parent of u? It is nothing but j minus 1th parent of u, 2 raised to j minus 1th parent of u, and for that nodes j minus 1th parent, right? So will be that, and then once we have got the values for this node, we can go to its children, because for that children this will be the parent, and for that children when I'll be calculating that, since this is already calculated, that okay, this looks fine. Now let's write the LCA function. Who is the LCA of given nodes u and v? Okay, so first thing first, if u and v are equal, you can directly written anything. Let's say u. If they are not equal, let's say depth of, let's say u is always at the greater depth, so depth of u is less than depth of v. We can swap u and v, right? U and v are swapped. Now go to u and v are swapped, that means u and v are swapped, that means u is always at the greater depth. Then find the diff. Diff is nothing but depth of u minus depth of v. So depth, and let's go take the jumps, which is equal to, let's say law, let's take greater jump initially. Can do in both order, right? So because all I worry about if the diff's jth bit is set, that means 1 left shifted by j. If this bit is set, that means diff and 1 left set by j, that means jth bit is set, then we can jump u as the parent, as the 2 raised to jth parent of u. Okay, after this, if they are equal, if v is equal to u, we can return u. Otherwise, so both v and u are at the same level, right? So we can say while the, now let's make other jumps also. So while their parents are not equal, we can keep on jumping. So but how much to jump? So for that also, let's start jumping. So can I jump? So 2 raised to 0. So can we make a jump of, can we make a direct jump? So let's go in the same order only. Think that is fine. J greater than or equal to 0 and j minus minus, right? So if j is equal to log 0, j minus minus. So if the parent of u, which parent, j 2 raised to j, is not equal to parent of v, j minus 1th parent, jth parent of this, let's jump it. U is equal to pr, parent of j, 2 raised to jth parent, and v is also the jth parent, and once we have, we can return the parent of u direct parent of u. So this will give me the LCA. Okay, so if u and v are equal, otherwise if v is at higher depth, v is at lower depth, that means u is at lower depth, that means u is at this point u is at higher depth. So let's find that difference and make the jumps. Okay, so I can only jump if and only if the set bit is true, and that 2 raised to jth jump. Okay, that means they are on the same level or they are equal. Okay, if they are equal, return. Otherwise let's again keep on jumping while this condition holds, while their parents are not equal. Okay, I take the higher jump. So initially higher jump, their parents must be equal. Lower jump, lower jump, lower jump. So first jump, then that by divided by 2 jump, divided by 2 jump, right? So this thing should work. Let's take the inputs. So we have the n and q, I guess. Okay, n q and what, n and q, then n minus 1 lines each describing for int I is equal to 2. So I less than equal to n, I plus plus. So if what key imply 1 is the general director. Okay, so what is that parent, what is that manager, we can say. Who is the manager of I mgr? That means adjacency of manager dot pushback. We can keep only one. Yeah, that also is fine. That means from manager to I there is an edge, right? That is what for each employee their bosses. So who is the boss of 2? That means 2 is the parent of I. Okay, then we calculate the DFS. After this we have this thing calculated, the parent matrix and the depth matrix, right? So depth and parent is calculated. Now let's read the queries. So while q minus minus, then read who are the 2 employees we are interested in. So we can see out the LCA of A and B, right? Do we need to print new line? Fine, I think this should work. Let's test this. Okay, something wrong at line 52. Okay, there's something wrong with my setup. I need to look into this. Let's try to submit this directly, or do we see NQ I0? Okay, manager DFS call, and then while read the inputs and then find the LCAs. Let's try to submit. Okay. Okay, something strange. What's wrong with this? Is it something wrong? I don't think it should be the case, but okay, that was not the problem. What is the problem now? Okay, First is fine, second is 10. Everyone's parents are 1. That means user output is 0. Why is 0? User has 0 input, 0 output also. Why when LCA can be 0? If I check any parent, that is -1. Let's see. So parent of u with j2 raised to j, u j-1, j-1 to log j plus plus. Okay, direct parent of u is the parent only. Now go to all the v over adjacency of u. If v is equal to parent, continue, then depth of v is equal to 1 plus depth of u. DFS on v with the parent as u. Okay, and q read in -1 lines and manager dot pushback I dot pushback manager, call a DFS on 1 since 1 is the director. Read the inputs, find the LCA of AB. LCA of AB is 0. That is weird. So if they are equal, then return u. If depth is smaller of u, depth of u is smaller than depth of v, that means swap u and v, and then find the difference. Okay, and keep on taking the jumps, or go to all the bits. Okay, one left shifted by j, and check if that diff, okay, that bit is set. If that bit is set, take that jump, so u becomes parent of 2 raised to jth parent of u. If they become equal, then return the u. Why? If u and v are equal, that means, yeah, so if u is at lower level and the difference, that is if they both are at same level. And what if I keep on jumping the u, right? If difference is 0, shouldn't it be written u? Otherwise go to parent and this are not equal, then u is equal to parent of uj, parent of vj, return the direct parent of u. Why can it be this one? Depth of u based on the depth we are calculating the parents, right? So if u and v are equal, return u. If depth of u is less than depth of v, swap them, otherwise find the difference and go on climbing. If diff is 0, then this won't be executed anytime, right? Then what if u and v are equal? Okay, to log j So if parents are not equal, parent of u 2 raised to jth parent of u is equal to parent u. Now parent u 0, q is equal to 2 to n minimizer goes back, and am I missing any edge? So 2 3 4 5, there is n minus 1 edge or there. No, there is no edge missing. So from 1 parent is minus 1. Why would it come to be 0 anytime? So parent, direct parent of u is the parent, okay. Direct parent of 1 is minus 1, and other parents like for u, what are the jth parent? 2 raised to, so first parent, that means 2 raised to, that is again, this will be what, this will be u and 0. For j equal to 1 it will be 0, that means minus 1. It is minus 1. So parent u of 0 is minus 1. So parent of minus 1, so that means who is the parent? I think this is wrong. We should make parent of 1 as 0 only, okay. 0, so that everything is be 0. So it is going in minus 1 location. Okay, strange. Okay, some complaining is also there. Input function void dfs iteration 24 invokes undefined behavior within this loop. Okay, at 12 and 20. 12 and 20. Two, three, four, 5. Oh, it is, if it is 25, it should be log plus 1. Okay. Okay, fine. what a silly mistake, yeah. Okay, so can we, I think this check is redundant because we are already handling this case here. Okay, and what if it is minus 1? Then what will happen? For j equal to 0, so who is the parent, or who is the direct parent of u is minus 1. That means for 1 it will find minus 1. You're right, so use 0. Okay. I think this will throw exception or not. What is wrong? So the parents should be 0 only. Okay. Okay, great.